Okay, the note packet, page 13 through 15, titrations and curves. Not really too much new in the first paragraph there, even these graphs. But it is important to realize that a weak acid titrated with a weak base, there isn't the straight line at the equivalence point, the vertical line. You know, every other substance, as long as a strong substance is involved somehow, you're going to have a near vertical section. But here with the weak substances, you're not going to have that. So usually no indicator is suitable when you have only weak substances. Okay, indicators are, here's a bunch of them, and they change colors. These are just four. Methyl orange, methyl red, litmus, phenolphthalein. You don't need to memorize these names, although phenolphthalein is the most common one, and it changes color around pH 9 or 10. Okay, you don't need to memorize the colors, you know, red to yellow or anything like that. Don't worry about that. But just realize different indicators change color at different pH ranges. Okay, so you know, with a strong acid and a strong base, the equivalence point happens at a pH of 7, but the graph is so vertical. Okay, right here, the graph with a strong acid, strong base, there's a huge area here. So pH of 8, 9, 10, you know, 11. So any 6, 5, 4. So any of these pHs, if the titration change is a strong acid, strong base, then any of these indicators should work just fine. That's why it says here most indicators. You know, we've got all these pH ranges, and that will fall at the vertical area somewhere, usually. So most indicators change color in this area here. And so because of that, a lot of indicators will work out just fine. Okay. Otherwise, if you have a weak acid and a strong base, a weak acid and a strong base means that this is going to be a basic equivalence point. The pH is going to be above 7 at the equivalence point. So you're going to want an indicator that turns above 7. So that's why I said phenolphthalein is a good one. Probably litmus could work too, but you would not use methyl orange or methyl red for a weak acid strong base. Okay? Alright, and then here's what I was saying before. A weak acid, weak base, there's no sharp change, therefore really no indicator will work. You should use a pH meter instead. Alright, the hydrolysis of salts. A salt, what this means is, you know, if you have a weak acid, if you have a weak acid like acetic acid reacting with a strong base, okay, you will make NaC2H3O2 and H2O. This is the salt. Okay, when you have an acid and a base, it will produce salt and water. Okay, and NaC2H3O2 is a salt, and this salt is a basic salt because this part of it right here is a conjugate base of this acid, acetic acid. Okay, so that would be a basic salt. Now, if you have a strong acid and a strong base, you're going to get a neutral salt. So strong acid, strong base, double replacement reaction, you're going to have NaCl and H2O. NaCl is a neutral salt. No hydrolysis occurs, no pH changing. That's what hydrolysis is. This next one, strong base, weak acid. Okay, that's like what I drew for you right up there. That's strong base, weak acid. Okay, and strong acid, weak base would be similar. Now here, a weak acid, weak base, You have to compare KAs and KBs, and that you won't have to worry about on the AP test. So don't worry about the weak acid, weak base. Just focus on these three scenarios. And that's it. Okay, that's all I needed to go over with you guys.